AIM 9.13 Graphs and Equations of Reciprocal Trig Ratios. So let's start off first with secant. Reciprocals flip the previous fraction. Notice y is equal to cosine of x below. When will the reciprocal value be equal to 1 or negative 1, and when will it be undefined? Well, the reciprocal is plus or minus 1 for all values in which cosine of x is plus or minus 1. It is undefined for all values in which y is equal to cosine of x is 0. And this means all times when cosine crosses the x-axis. The blue graph here represents secant of x. Notice that both graphs have the same value when y is equal to plus or minus 1, but secant is undefined at 0 because the reciprocal of 0 is undefined. When a secant reaches a point in which it is undefined, it creates a vertical asymptote. This accounts for the flipping and jumping of secant. Cosecant. Notice the graph y is equal to sine of x. When will the reciprocal value be equal to plus or minus 1, and when will it be undefined? The reciprocal is plus or minus 1 for all values in which y is equal to sine of x is plus or minus 1, and is undefined for all values in which sine of x is 0. The blue graph here represents cosecant of x. Notice that both graphs have the same value at plus or minus 1, as shown by the fact that they are touching. But secant is undefined at 0 because the reciprocal of 0 is undefined. And once again, this creates vertical asymptotes, which account for the flipping and jumping of cosecant, as shown below. Cotangent. Notice y is equal to tangent of x. When will the reciprocal value be equal to plus or minus 1, and when will it be undefined? The reciprocal is plus or minus 1 for all values in which tangent of x is plus or minus 1, and it is undefined for all values in which y is equal to tangent of x is 0. This is the graph of cotangent. Notice the points in which they are both equal to 1. These actually occur at pi over 4 and iterations of pi over 4. This is because on the unit circle, your coordinate there is rad 2 over 2, comma, rad 2 over 2. And when you divide, tangent of theta is also known as y over x. So if you take the square root of 2 over 2 divided by the square root of 2 over 2, you will get 1. And so this occurs at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, with the pluses and minuses respective to the quadrants. However, it is undefined at negative 2 pi, negative pi, 0, pi, and 2 pi because tangent at those points is equal to 0. This creates the flipping and jumping and the vertical asymptotes. So now let's try a linear reciprocal equation. 3 secant of theta plus 4 is equal to 0. So we must solve for all values of theta such that theta is greater than or equal to 0, but less than 360 degrees, rounding all values to the nearest tenth. Secant of theta is equal to negative 4/3. And we get this by transposing the 4 and dividing each side by 3. I'll correct that typo when I post. However, we don't have the cosecant of theta function on our calculator. However, we know that the reciprocal of secant of theta is cosine of theta. So we can use that, but we simply need to flip the fraction. This does not lessen the integrity of the fraction because all equality is retained because we flipped both sides. And then we do the arc cosine, the arc cosine of negative 3/4 to get theta. And we know that Cosine is negative in quadrants 2 and 3. Therefore, our first answer would be 138.6, and we determine the reference angle there, and we add our reference angle to 180 to get 221.4 degrees for quadrant 3. When the ratio is greater than 1 for sine and cosine, it is actually undefined. This is because the highest value for sine and cosine is 1. And you can look at the unit circle. Notice how it doesn't exceed 1. And also the parent graphs for sine and cosine. Your homework is a delta math. Please provide your scrap paper for reciprocal linear trig equation.